This video is part 3, and just another example of chapter 11.1. This is our first one here. Here are the steps in your note sheets of how to run a hypothesis test and confidence intervals. So again, in this little chapter 11, we add this idea of using confidence intervals, putting it all together, using confidence intervals to also make a decision. So if the confidence interval contains 0, then we were able to do not reject the null hypothesis. If it doesn't contain 0, if it does contain 0, we do not reject. If it does not contain 0, then we reject. If it contains 0, we do not reject. I'll make a note of that. So for confidence intervals, got to add this there. Confidence intervals. Right, for confidence intervals, we have to make a note of this here. If the CI contains 0, there's the word contains, not contains, contains 0, if it contains 0, we do not reject. And if the CI does not have 0, does not include or have 0, if it does not include, or the word again that we use is contain, like, because the confidence interval is like a container. Does it hold 0? Does not include or contain 0? If it does not, we reject H0. We do not reject H0. That's key there. Okay, let's go ahead and do another example. Looking at testing a hypothesis regarding two population proportions. Here's another example. Go ahead and read that, and I'll set some of that situation up. Read it first. Okay, so we're looking at an experimental study where a random experiment, random groups, people who took a drug, the proportion who took the drug got 26% got headaches. The control group who got a placebo, just so if you never heard that word, placebo, it's called placebo, got a fake, like nothing, like a water pill, salt pill, something, right? Something different than that doesn't affect them. And then 22% of them got headaches. So we're going to go ahead and we want to test the claim. Is there significant evidence to conclude that the Nasonex users is greater headaches than the control group? And so what this is going to then look like is this. Our null hypothesis would be that the proportion from group 1 is equal to the proportion, no hypothesis, no effect, nothing happened in that experiment, right? And then the alternative is that P1 is actually greater than P2, that if we actually looked at the population of proportion, that this would be the case. We're testing alpha equals 0.05. We have the values. Our current evidence suggests that P1 does, but is that statistically significant? So we go ahead and run our, we're going to run our hypothesis test on this. So you go back to stat. Let's go ahead and do this again. Get out of there. Stat, proportion stats to sample with summary. Let's go ahead and put it in for the first group. The first group that was 547 out of the 2103. Successes for those for the next group, the placebo group, control group, 368 out of 1671 got a headache. What's our hypothesis test? Our hypothesis test is that P1, well, null hypothesis is equal. The other one is that the first one is greater than the second one. And compute. Test statistics 2.84. 2.84 and 0.023. 2.84, so our z value is 2.84. It's a pretty big z, which means it's going to give us a very small p-value. If the p is low, the null must go. And then since we have, you should be getting good at this, I'm going fast now. Since 0.023 is smaller than 0.05, we reject H0. We reject that. So we're saying this is not true, and this is, we believe, we have evidence to support that. So we think there is sufficient evidence to support the alternative hypothesis, to support that Nasonex users got more headaches. And so that company would say, oh, we might have a trouble here, it causes headaches, or that they would have to warn the public that this may cause more headaches for those who are taking it for allergies. And so there's our conclusion. Now we want to also use a confidence interval to do this. So let's go ahead and create a 95% confidence interval. Let's check to see. This is another way to run a test here. And so we're going to do the confidence interval. We'll use StatCrunch to do that. It's just an alternative way. Thought I hit edit. There it is. And so let's run a 95% confidence. So comparing the two means, compute. That's it. And we get 0.012. I'll go 0.01 to 0.07. 0.01 to 0.07. Just rounded to decimal places for now. 0.01 to 0.07. And so what does this mean? 0 is not included in this confidence interval, which means we're saying that these two are not equal. The difference between them is not 0. It's if the confidence interval contains 0, do not reject. If the confidence interval does not include or contain 0, we reject. Since 0 is not in this confidence interval, we're saying these are not equal to each other. And so what do? What does the results mean? Since the CI does not contain or have 0, we reject. We're 95% confident to reject. We reject H0. And then that, again, would say there's sufficient evidence to support. The point estimate for this, halfway, that's 6, 3. The point estimate is 0.04. So we think the actual difference between these two is around 0.04. And then the margin of error would be with the margin of error 0.03. So it's like a 4% difference. That's what we would think between those. And I forgot to include that here. We would say here, we think it's a 3% difference, but it can go all the way down from -2 to +8, which means there was no difference here. And so that's how we would then use this to interpret, do a hypothesis test using confidence intervals. That's how we would do it. That's it for 11.1.